Hello, I'm Christian Hübschle and I'm an author of the program called ShelXle, and today I want to show you some basic steps with the program. So first thing is, of course, we start that program. So it will look like this when you start it the first time. And it is for refining structures with SHELX. And for that we can just drag a file like this and probably make this a bit larger. As you can see, there's an overlay for any keyboard and mouse action, so you can always see what I am doing with that mouse and keyboard in the background. So what I want to show first is you can move, that's the editor where you see the input file for SHELX with syntax highlighting, and you can move it in any area of the screen as you wish. So I prefer it to have everything on the left side. You can leave it if you want on the right hand side. So here's the output window and also the list file window, and let's move that over here. As you can see, of course, there's no structure yet because this structure isn't solved yet. We will do that in a second. This is the information window, which contains important information, so probably we want to see it, so put that down here. Here's the refinement history, where you can go back and see how good the refinement goes on. So let's do that. And there is also a renaming window. We will use that probably later. I also move that here in that way, and you are always in the rename mode when you see the renaming window. So if you don't see it, you are not in the rename mode. That's some kind of concept of that. In order to refine structures with SHELX, you need to specify where ShelXle is. So we can do that here. We just click here on Browse, and now we just select the executable where you installed George Sheldrick's ShelXle or a Brooker variant XL, for example. And yeah, we do that by just clicking OK. There's an option that you can specify any command line options. ShelXle will tell you that on the output, but we don't need that at the moment. So we can leave that window like this. And still we do not have any atoms yet, so we need something to solve the structure. The most convenient program for solving a structure is shelxt. So let's call it just xt. And I'm browsing here. Here is it, shelxt. And as this icon is not very self-explaining, we can have text overlay and resize this kind of text in a way. There's an option, of course, for command line options, or we can have different file extensions, might be useful. Not at the moment for this program. Of course, if we run xt, we want to have the file name as an argument, and with all SHELX programs we have to omit the res or ins extension of the program. Any program which has its own window should be started detached, so it's not connected with the program anymore. Otherwise, if it's just a text output program, the text output will be piped into ShelXle, and you can see it from there. And in this case, it's probably a good idea to copy the res file into the ins file, because this program always tries to edit the res file and copies the ins file just before action. So let's add the program, and we can see here there's this icon now, and also here in the menu there is a menu item. So we just click here on XT and say save or discard or cancel. But as this kind of window might be annoying, you can here click once always, and you will not be bothered anymore with that annoying thing. And now we see here there is some previous ints file, some other ints file, and as this has only one solution, which is called A, we have here 6018 underscore A dot res, which is our current solution. So we click this button here, and here we are. That's the structure. It's a fullerene attached with 18 fluorine atoms, and as you can see, those labels here all over there have some kind of a funny order, so probably you want to rename them, and we can do so later. Yeah, as you see, we have some kind of a perspective view, so everything in the rear gets smaller and things in the front are larger. Yeah, you can scroll with the mouse to change the label size if you need or want, and there's also option to have the orthogonal projection, which then looks like this. So you see all rings are the same size, so probably you prefer that. Of course, you can have the unit cell box around it, or you can switch off the labels, the bonds, or you can have ADPs or normal style. In this case it's ball and stick, but you can switch to tubes. Many options over here. So we specified the ShelXle executable, so we can refine the structure. So we just click here on refine, and as you can see, here's the output. Here in red there's a warning. This instructions may be required for these wavelengths. This structure was measured on a synchrotron, so it is not common wavelengths like silver, molybdenum, or copper, or something like that. So we can just say here load refinement results, and now we have this QPeak legend, and so we have to arrange everything again. Should have done it in the other sequence. So like this. So this is how I like that. So so this, what does this QPeak legend mean? You can click here to hide any QPeaks which are residual density peaks in your structure, which are lower than the value you clicked on. And if you hover the mouse here, you see some highlighting on some of the QPeaks which have the corresponding electron density value. So and when you hover with the mouse on QPeaks like this, you see there's some highlighting in that legend going on. So, and another feature I haven't shown yet is if you click any atom like this, the cursor in the editor will jump immediately to that atom in the file. And this works also in the other way around. You can say here, locate C019 in the structure, and this will center and select that particular atom. So let's unselect it, and here we reset the rotation center. Fine, and as I see here, we have another problem. This font seems to be a bit odd. So yeah, to change the font of the editor, we just go here into settings, change editor font, and here it is on a default font, which has the problem that it is not monotype. So we need a monotype font like Courier or Courier New would do that. I prefer some font you can find in the internet. It's called Droid Sans Mono, which is used by Android devices. It's for free. Just Google it and find that. So let's choose that, and now you see everything is more cleaner in shape. Yeah, there's a new feature inside, which is very easy for use, which is called Autolabeling. It's currently in the testing phase, so it might not work on every structure, but maybe let's try it if it works on this structure. So we click here on Autolabeling. It will then explain how it works and what you need to do if you're not starting it from the beginning like we do now. So we just click here on OK, and then it takes some seconds. You see probably that some of the labels start changing, and the mouse cursor here is curling around. So it's finished now, and it says that 78 atoms out of 78 atoms in the assembly unit were relabeled. So it has done the job. And let's see, so here's C1, C2, C3, C4, 5, 6, and then it goes here is 7, 9, 10, 11, 13, 15, and so on. So it would have been some kind of work to do that by hand. Probably I can show you later how this works. Yeah, of course, one thing, if you right-click on an atom, you will have a context menu which changes on every time where different options are available or not. So don't expect that you know everything about that menu just by trying once. So what is this structure at the moment? You see here there's just one number in that row, which means there's an isotropic temperature parameter. And of course we can go here into the file and type in anis for anisotropic temperature factors, like this. Or we can just do it by clicking here on this button, insert anis and run SHELX. You find that functionality also here. You can also just press Alt and F2, so every shortcut should also be written next to the menu where you find it. So kind of convenient to do that like this. And here is the list file. Here, by the way, you see command line options which are possible for ShelXle to tweak it if you have some problems, but usually you don't have to change anything here. And you can scroll down and you see here there was this warning. This instruction may be required for this wavelength. The structure was measured at synchrotron radiation, and therefore it is not at the common wavelength. As you can see here, it's somewhere in between molybdenum and silver radiation. And here's a convenient functionality for that. We can just click here on dispersion from wavelength, and now we have the appropriate dispersion commands here in that file. As you can see, if you hover the mouse on any command, you will see some kind of a short description, and if you hover the mouse and press F1, yes, I want to use that, you immediately jump to the website where this command is explained and what it does. So very convenient, I think. So with that, we can again refine. Doesn't matter if you use refine anis or refine in the usual way, because the atoms are already anisotropic. So as you can see, yeah, it worked out. And here you see in the refinement history with isotropic thermal displacement parameters, the R value was something about 13%, and it went down to 4.63, and with that disk command it was going down very slightly. There's this functionality inside that you can show residual density maps. If you press here, you see we have a lot of green meshes in this structure. This was a charge density data set, so there's a lot of electron density on the bonds, and which indicates there's some bonding effects going on. And if you use that, you see there's the blue mesh around. That's the observed density with the phases of the structure. You see this is also quite nice. So you can change anything concerning with the maps with that map control button. Can change the area where this is drawn. For example, you can have the complete unit cell or just a sphere around the rotation axis, and you can or rotation center, and you can change this radii and the cut range for if you just have a cut range around the visible atoms. You can also change this cut range like this over here. Click on apply, so you see the density is there. We can change the line transparency, or we can change the line width. So you can have also filled surfaces if you prefer that. Where's our button here? So, and even for example, if you have problems recognizing any of those colors, you can change them for yourself. And there's also option to have the factual dimensional analysis, which should be a perfect parabola. In this case it's not, because we have strong bonding effects and those need to be fitted for that structure. So you find this option also over here in the tools menu. Yeah, let's go here again. I changed that back, and so something I haven't explained yet is you can change the value of the map very easily. It's written here. You just, for the observed density, you just use the shift key and scroll up and down, and this will change the value of the map. Please be careful, do that a bit slowly, because otherwise your computer might be busy for some time. Okay. Yeah, so when you gone so far with that structure, probably you see here there is a weighting scheme. This is just a default weighting scheme, and if we go down in the structure, here we see ShelXle recommends a different weighting scheme, and we could just copy it up in to the other command and refine. There is an option to do that by just clicking update weight instruction like this, and then we just refine, and you see it here. It has used that one, and it has recommended a slightly different one. So we can repeat and repeat that, or we just click here on that icon, which is the same as this menu entry over here, and then the program tries to repeat that procedure up to 10 times, or until the values converge, which is not always the case. And so now we can load that results. Let's see if we see something in this R value. So we, with dispersion, we had 4.62%, and now it's going down to 4.52%, which is a bit better. It is not always the case that the R value gets better, but the fit internally is better. So it's generally a good choice to do that. What we see here is that we have a unit instruction which is not correct, and it's also very easy to correct that. So we just click here on update unit instruction, so it will count the number of each type of atom and will put that over here. So you can use refine, and we probably also want to have later a zip file, so we can just introduce the acta command, which probably introduces more error messages which were not there before. Okay, our input data was merged, so we cannot determine if the handedness of this molecule is correct or not. I guess it doesn't care, because I think it's rather symmetric. So we can of course search anything in our file. So oops, I'm not here in the so it immediately jumps to the first occurrence. Of course, if they're next and so on, you can replace it, and this thing also works with regular expressions, so you can do really complicated search and replace tasks with that if you want. What else? Yeah, as you can see here, we have this refinement history, which means that you can just click on any of these bars and you go back to that ints file which produced that L value. So if we would click here and refine, we will end up here because all the inputs are already made in that input file before that. So there's another option for history which is called Save History. You can click here in this yellow area over here, or you find the same thing here, Open Save History. Let's do it here. What is it? You have here your editor in the same color scheme as you see in the normal editor, and additional here are some buttons with dates when this file was saved, and you see then in orange what has changed to the current version. So I think that's rather convenient, hopefully. So of course there's some undo and redo things, and if you want to increase the font size or decrease it, you can do so here. If you don't like it in that upper row because of space reasons, for example, you can attach this edit toolbar to the editor and move it around that editor sub window if you want. So yeah, there's of course this button where you can hide all these text windows to have a greater view of your structure, and you can get it back of course like this. For now, this is it for today. I hope you enjoyed it, and probably you can leave in the comments what you want to know in the future. Thank you.